Hey guys, today we'll talk about finding the volume of prisms and cylinders. We've talked about surface area for a little while now, so now we're going to go ahead and switch gears to volume. So just to start, what even is the volume of a figure? And basically that's just like the cubic units of space that you can fit inside of some kind of three-dimensional figure. So how many cubic units fit inside a figure or a container, or if you wanted to find the volume of a box, that would help you understand how much space is inside of that box or how much space is inside of a cup, etc. So this is more of an inside thing, whereas surface area was certainly more of an outside thing. I'll write the word container here too, why not? All right, so we're going to just go ahead and talk about the cylinder first. If I wanted to find the volume of a cylinder, I have this handy dandy formula here, and basically it's just the area of the circular base, that's where this pi r squared comes from, times the height of the cylinder. Whoops. All right. So if I want to find the volume of this cylinder right over here, I would just plug in my information. So I know that the radius is 3 inches and my height is going to be this 10. So I'll plug in the 3 where I see an R, and I'll plug in the 10 where I see an H. And at this point, it's just a calculation game. So pi times 3 squared is 9 times 10. And this is essentially going to equal 90 pi. Now, I would want you guys to actually type that in your calculator and get the whole decimal. So when you do that, you should get 282.74. And we'll call this inches cubed because volume is always in cubic units. Kind of like how anything area related is always in square units, volume is always cubic. All right, so that is all there is to finding the volume of a cylinder. So we can go ahead and move on to prisms next. There really isn't, well, the idea is pretty much the same. Like for the cylinder, we found the area of the base and multiplied it by the height, and that's exactly what we do for prisms as well. We're still finding the area of the base and multiplying by the height, but I just wanted you to see that we can just embed the formula for area of a circle into the cylinder one. So if I'm working with any prism, meaning triangular or rectangular, I can use this base area times height formula. Something worth noting is that if you are working with a rectangular prism, aka what you guys know as a box, you can just do length times width times height, and in just a sec I'll go over that. You'll see that it's doing that is pretty much the same thing as doing base area times height. So for this example, we have this box with these dimensions, and if I wanted to follow this base area times height formula, we can say that my base is a 6 by 3 rectangle. Okay, it's right over here. 6 by 3 rectangle, and the area of it would be just base times height, so 6 times 3, giving us an 18 square centimeter area. All right, so then to find the volume, you just do base area times the height of your prism. So if my base is right here, my 6 by 3 rectangle, the height is this side. This is my height right here, the 4. So I would plug into my formula the 18 for the base area and 4 for the height. All right, once you calculate that, you would get a total volume of 72 centimeters cubed. Now again, I wanted to mention that there's this little shortcut for just the rectangular prisms. Like it wouldn't work for the triangular one, but we can just do length times width times height, meaning that these 3 dimensions that they gave us, we can just multiply them all together to find the volume as well. So length times width times height, meaning I would just do 6 times 3, that's my length and width, and my height is 4, so 6 times 3 times 4. And notice how ultimately that's pretty much the same thing, right? In this first version of the formula, we did 6 times 3, got 18, and then multiplied it by the height. In this case, we would just all do it in one step. So that's how you can tell that it's the same thing. It's just easier to remember length times width times height. And someday you'll probably have to find the volume of a box at some point, and that's probably the one you would remember. All right, so now let's go ahead and switch our attention to this triangular prism. Now, it's just important to note here that the bases of this prism are the triangles, not this rectangular bottom portion. You can think of this as being a prism that's laid on its side. So really, the bases are these triangles. And remember, in prisms, there's always two bases that are parallel to each other. So these are our bases. That's how you know that that rectangle that this prism is sitting on currently isn't the base, right? There isn't another one across from it that's parallel. So the first thing we want to do is find the area of that triangular base. So that's going to be the base of the triangle times the height of the triangle divided by 2. Now the base of my triangle is going to be 10. The height of my triangle is going to be 8.3. All right, so if we were to calculate that out in our calculator, we would get 41.5. So 41.5 square centimeters. So that being said, we can plug that into the volume formula now, which is base area times the height. So we would do 41.5 times our height of our prism is going to be this 14. Now, it might be a little confusing to recognize this as the height because it's not vertical, but remember what I told you about this being laid on its side, right? This prism is laying on its side, so you have to remember that the height of a prism is always actually the distance between the two bases. So my height is 14. Now I can just go ahead and calculate this. And I'll find that my volume is 581 centimeters cubed. All right, and that is all for today.